Hello, I'm Jonna Mazet, and I'm very happy to be with you today to talk about One Health and using that approach to really try to solve emerging health problems, especially emerging pandemic threats and coronaviruses. As we all know, we're incredibly vulnerable. There's on the order of 3 new emerging infectious diseases in people each year. And almost all of those are coming because of our interactions with the planet. And that's why I truly believe that One Health is a critical approach that can really help us move into the future and away from the devastating consequences that we're seeing with COVID-19. Now, can we use this approach to go even further and address what we yet do not know? And so by that, I mean, not just look at COVID-19, look backwards, and not just acknowledge that we're going to have this disease for some time, as well as influenza, but be considerate and aware and ready for anything else that might come. And I do think the One Health approach can help us significantly with that. Before we started the PREDICT project that I'm going to talk to you about, there were about 240 zoonotic viruses known to make humans sick. Because of the work we've done, we've been able to actually estimate that there are probably about 500,000 more or 500,000 more viruses that can infect humans, not necessarily all make us sick, but that should be on the watch list for things that we should be ready for. And I really think that One Health can do that. And for me, One Health has 2 central tenets. One is that it's collaborative, bringing together many different disciplines to address problems in ways that we have never done before. And then the other side is that we're looking at the intersection of what used to be called human, animal, and environmental health. But I think I'm really happy with the progression to pull plants out separately and consider the food systems and food supply separate from the environmental piece. I think that's critical. And so I think if we can bring these pieces together where we're looking holistically and working together, we really have a chance to do so much better than we did with this one and that we have throughout history. Now, if I take that same Venn diagram and list some of the problems that we're dealing with, obviously, as we're all still mostly in sheltering situations and can incredibly connect with the devastating consequences of zoonotic disease, we have to be thinking about those. But loss of biodiversity, I think, is an important topic for us today. And that is another huge piece of this puzzle that One Health can help us address and hopefully help us address together. Now, we'd be remiss if we weren't thinking about the drivers that I've also listed on this slide, just as a few examples. But land use, climate change, economic development, and globalization, all of those things work together to enhance problems, and we need to think about them more holistically to prevent or mitigate the problems that we already have. So about 11 years ago, almost 12 years ago now, a team that I was lucky enough to lead started with the U.S. Agency for International Development, the PREDICT project. And the idea behind the PREDICT project was to find viruses before they spill over or be ready for them when they do spill over to be able to mitigate and reduce the epidemic curves. And for us, that meant we really focused heavily on forecasting and readiness and laboratory capacity for early detection. And we were looking in this green area, or what we call the zoonotic pool. So the viruses that were circulating, especially in wildlife, and available to spill over into livestock and people. Now, when they do that, the sort of dotted line up top and the white area, that's where things get out of control. And when we respond too late, we have no chance to shrink those curves. And so the idea behind using One Health to be more proactive is to move all of that response to a more proactive spot and be ready and detect and then respond really early. And that can shrink the amount of virus spilling over from wildlife into livestock, directly into people, or into livestock, allowing the increase and amplification in the livestock and then into people. And the goal, again, is just to reduce those epidemic curves and have many fewer cases and more effective responses. Now, obviously, in COVID, that didn't happen. And we can talk about why. We should talk about why. We should use this lesson to never let it happen again. But we need to build the confidence in science and the political will to act on the science if we're aiming to reduce these curves. So with the project, we went out and worked with more than 30 countries around the world to really start to think about their zoonotic pools, what was circulating in wildlife and livestock and people, but with a heavy emphasis on wildlife, and understand how to safely detect those viruses and be ready for them and work with them in the field and in the lab. And what were we able to achieve? Well, I think, what many people focus on is that we found virus. So we started a project, we sort of built the plane while we were flying it. How do you go out on this large scale and detect and identify not only viruses that you didn't know about before, but also the systems to be safe, and then to use that information to communicate to communities, engage with communities, to prevent the actual risk factors that we documented with behavioral investigations that put people at risk for interacting with and becoming infected with those viruses. So we did sample about 164,000 individuals. Again, most of those wildlife, but many livestock and humans. And we also partnered with FAO and WHO to do that work. And then we got that One Health workforce, almost 7,000 individuals in the countries where we worked, to be doing this in an incredibly safe and informative and collaborative way, and working with more than 60 laboratories in the countries to really bolster their systems to detect any virus that might come their way. Really, that workforce and those labs create what I like to think of as almost a global immune system. They not only help us to identify threats before we're experiencing them, but to jump in quickly and put in the risk mitigation measures that help us control, which didn't happen on this one and need to be addressed for the future. So what about coronaviruses? So I mentioned we found about more than 900 novel viruses, about almost 300 known bad actors, known viruses using the same platform. I think that's important as well. So these labs can detect knowns and novels. When we detected the knowns, we were also adding to the rich information about important viruses that make people sick, and identifying new hosts and identifying new locations where people weren't looking for those viruses beforehand. But I think if for our conversation today, identifying about 177 coronaviruses, more than 160 of those brand new coronaviruses to science, helped us to really identify host ranges, how their binding, receptor binding is working, where we should be looking for them, what kind of interfaces. And that helped a lot in the countries where we were working. Absolutely, with COVID-19, they jumped into action. Their labs were ready. They responded immediately, and some of them had the best outcomes of many countries around the world. It also helped us with the science to be able to look for where this might go and how we can control it in the long term. I am a veterinarian. I'm an epidemiologist with a veterinary background. And I think it's interesting to note that coronaviruses have been very important veterinary pathogens for decades. So while there are 7 known human coronaviruses, for more than 30 years before we knew about human coronaviruses, the veterinary community was dealing with coronaviruses that affect the food supply, frankly, also our pets. And so that's just another example of this power that if we're working together, we could be looking more completely at the complexity of what's happening in our natural environment and preparing for the future. In the Predict project itself, one of the first things that we had as an early important discovery around coronaviruses, in addition to finding new ones and starting to map them and understanding regional differences and host differences, we were able to actually identify that rhinophyllid bats were really important with SARS and SARS-related coronaviruses, and start to think about and identify the ACE2 receptor as showing that actually the viruses didn't necessarily have to go through an intermediate host. They could spill over directly from bats, and obviously spill over also into intermediate hosts and be available even more broadly to people. So we got out there, we looked at a lot of animals, primarily non-human primates, rodents, and bats. And the bats were definitely the richest source of our discovery of coronaviruses. And I think one really important thing for discussing today is that we were able to identify different classes and variants within the SARS viruses or the coronaviruses, and including the SARS-related viruses, and the SARS coronaviruses here were predominantly infecting and being detected in rhinophyllid and hippocyterid bats. That was incredibly helpful because we could say, look, the most likely suspects of where we should be looking for the risks. And again, the risks that people put themselves in. The bats are not leaping out and making people sick with their viruses, and the viruses are also not available to just attack us. It is how humans, we are behaving with those bats and with the environment that are putting us at risk. But understanding their hosts helps us to start understanding where we might be looking and enhancing surveillance in humans and be ready for these viruses. And here's an example of that. If you look at the distribution of bats that harbor where we detected SARS-related coronaviruses, you can see that it is not just China, and that we should really specifically, if you look at the Rhinophilus affinis map here, we should be looking at all of Southeast Asia. And that's proving to be correct as we are detecting more and more and going into archive samples and things and finding more SARS-related coronaviruses that all help us build the picture of what happened here and the likely evolution of SARS-related coronaviruses. We're also able to start to identify other coronaviruses, likely evolutionary strains of important coronaviruses like MERS-like coronaviruses, and even identify cryptic biodiversity with this bat actually being new to science when we found a MERS-like coronavirus in it. And we're able to start to look at this bat and its most closely related cousins that were filling the same niche and start to look at their distribution and where maybe we should look for the evolutionary source of MERS and how that overlaps with camels and camel breeding and all of that good information. Also, we could look at the risk factors. So we were doing a lot of work with humans, behavioral surveys, serosurveys, testing them for viruses in the same interfaces as animals. And, you know, the large market hypothesis and concern has been very important. And you can see here that when our teams in Vietnam were sampling in the field at the same interfaces where trappers and traders were collecting rodents to take them either to farms or to large markets, we're seeing about 20% of those rodents infected with coronaviruses. Then, of course, with the intense husbandry, stacking up and mixing at the market, we saw that grow to over 30%. And then most concerningly, by the time that those same rodents were getting to the actual end user, the restaurant and the consumer, we saw that they were infected more than 50% of the time, making coronavirus available to those clients in that restaurant interface. So we're able to really start to map these risky behaviors that can inform mitigation, behavior change, and all of those interventions that we need to keep this from ever happening again. In addition, we're able to start to pull together risk factors, not only virologic, which are critically important, but also risk factors including the ecological and epidemiological occurrence of hosts and contact with humans, and put that all into a web interface there where people can enter their own new viruses and sort of crowdsource this information, but also to rank them for riskiness, but also start to rank and make that watch list for increased surveillance for the ones that appear to be most risky. And if I just pull up here an output from that application for coronaviruses, you can see that SARS-CoV-2 is at the top of the coronavirus risk list for spillover, which has some indications for spread as well, and that one of our predict viruses ranked very highly as well. We call it predict 35, but it down at the bottom of your screen. And this looks like a credit score because we are looking at multiple factors that include host factors, environmental factors, as well as virus factors. Finally, I just want to make sure that we all take this message out to all of our networks and colleagues that we need to protect bats. Bats are critical for ecosystem services, protecting biodiversity. We need them. They're pollinators, they're seed dispersers. They also are insectivorous and protect our crops. And attempts to reduce bat populations are generally unsuccessful. They encourage recruitment, making more bats. They also have been shown to increase the shedding by stressing the population. So we need to protect bats. And to help do that, we put together community outreach materials, including a book that's designed in 2 different forms for Africans and for Asia, Living Safely with Bats. And it's been translated into more than 12 languages now, so I'm thrilled about that. So thank you for letting me share with you today. I look forward to the other presenters and this important session. So take care.